G'day guys, I thought I'd just throw this one in. Have a look at that waveform there. That's normal timings in a GPX. And have a look at that initial big kick up on each of those receive timings. That's pretty standard in these GP, GPXs or any of these detectors, these types of detectors. And you can see basically a lot of jitter and so forth, bit of carry on there. What are we on? 5 millivolts, so it's about 5 millivolts peak to peak of noise on the main band. You can see it there, but further on there's a lot of, if I crank the brightness up, you'll see it that it extends probably 10, 20 or so millivolts. But it's jittering around, a lot of 50 hertz on that. Now I'll show you what this should look like with our redesigned input stage. I'll just take it off channel 1 and I'll put it on channel 2. So there you go. That is a properly compensated input stage. It's very, very flat. It's very turns on very fast, and it's working really well. So you don't really want to look at the detector. It's just a big mash of wires at the moment and boards. As you can see, I've just ripped out the whole input stage, and on the back of the board as well, taken out everything and rebuild it on a couple of boards. Well, actually there's 4 boards, but that's the difference you get. And even so, this is just normal gain. It's nothing, it hasn't even got a variable gain board. It's got no variable frequency or anything like that. It's just bare bones basic. And on this I'm in normal mode. Go up here, have a look at the coil wherever we are. Hang on, I'll zoom out a bit. I'm holding this by hand at the moment, so I've got a roll of sticky tape up there as sort of a measure. So this is normal mode. Oh, probably, I don't know if you can hear that. Maybe it's not loud enough. Hang on, I'll just turn it up. All this is factory default, running about 35 microseconds on those short pulses. So still getting it. I'm missing it about there. That's pretty high up. That's normal timings on the 0.05. That's pretty good. But you can probably tell that it can be a lot quieter. I've got to do the other channel as well. And yeah, have a look at that. Look how flat that is. And it's really responsive too. It's probably jittering all over the place putting it on a video. But yeah, if you can see those straight lines there, there's no massive upswing unless I get a, I'll get the hot rock, and then we'll start getting a bit of movement. There we go. Have you noticed that even with the standard front end, it's already peaking on nothing? It's already peaking, and usually that initial peaking is caused by too much capacitance in the feedback loop. I removed all the capacitance, still peaks like crazy. And this one here, there's hardly any peaking whatsoever. It's really good. So yeah, that's a big advantage. The other thing as well with this, if I'd have to wire it up as a dual mono setup, but there's actually a lot of reduction in 50 hertz noise in the new setup as well. So we're not doing anything on the input, we're just doing it in a roundabout way. Like I say, as soon as you say anything that gives the game away on metal detectors, it will be stolen by commercial interests. It'll be, if you haven't done anything about it, it'll be patented and you'll be locked out from your own hard work. So the trick is not to say anything. Just don't give the heads up on this sort of stuff, and make the detectors better for your own customers. I'm not making it better for commercial interests. Yeah, they'd patent the leg of a bee if they thought it made their detectors different. So yeah, it's just my take on things. Yeah, a lot of people have said a lot of things about commercial interests over the years. Some of it I agree with, some of it I don't. But you can give the whole, I suppose if I really wanted to, I could say, okay, this is how I do it, do the whole thing, publish it on YouTube, and then it would be very hard to patent it as an innovation on their behalf, because I've already made it public. But by doing that, all it's going to do is just trigger a whole heap of copycats doing the same thing and telling everyone they invented it. So not the case at all. This is all my own work. And if it was, how'd we say? If it was, invented by others, it would be in the detectors, and it's not, right? So why is it not? I don't know. Next model? I don't know. But yeah, that's how we can control the receive window. I might have given it away a little bit in a previous video. But you can see that it's smack on, perfect. It's actually absolutely perfect between the two rails. I've got it elevated up a little bit because I was using the input on channel 1 and channel 2 there, so I had to separate them, otherwise they both overlap. Actually, I can put them both on and have a look at the overlap if you want. What to do this one, just adjust them the same. What have we got? Sorry, that was wrong. Okay, if you have a look at that, that's both someone walking in my coil with metal, with a phone. There you go. So that's those two signals on channel 1, channel 2 overlapping. I'll just move them apart. And you can see my nice flat one up the top there. And you look at the bottom one, and the bottom one's got a lot of 50 hertz mixed in with the signal. You can see that, the gap. I don't know if you can see it, but there's a gap in that long straight part, which actually kicks up at the start. And the other one's flat. And the other one's got less noise, as you can probably tell as well. So yeah, that's what I'm working on at the moment. And the noise generated for this detector is probably from the channel that has all the noise. I'll build up another set for the second channel, second input, and put it on, and I think we'll cure a lot of the noise issues with these detectors, and sensitivity, depth performance should go through the roof. Anyway, catches.